So this question has given us a box plot already drawn, and it wants us to interpret the box plot to find some values. My advice whenever you see a box plot question is to kind of sketch out your standard box plot and remind yourself what the values are at the key points. So the box plot always starts with a minimum value, and the box itself starts with the lower quartile. The line in the side of the box is the median, and the upper quartile is the end of the box, and then at the end of the whisker, at the end of the box plot itself, is the maximum point. So we know that's how the values go, and then we should remember that to calculate the interquartile range, then you always do the upper quartile value, take away the lower quartile value. So that's the kind of picture that we should have in our mind when we're thinking about box plots. So let's see, write down the median. Well, the median is the line that's inside the box, so the median value is going to be here. We should always be thinking about scale, so be careful of scale. So on this particular question, they're telling us that each little square is worth 1. So this is going to be 35, 36, 37. So the median is going to be 37. For the interquartile range, well, from the formula, we know that the interquartile range is the in-between quarters, so we need the upper quartile value minus the lower quartile value. So the upper quartile value from this graph is here, so 71, and the lower quartile value is here, which is 31, 32, 33, 34, 35. So we're doing 71 take away 35, which is 36. Do a back check, 60, 71, yeah, so 36. Okay. Then the question goes on and talks about another distribution. So table shows the number of countries competing. So this one was about the Winter Olympics, and this one is about the Summer Olympics. So we're comparing winter and summer. So this was for the Summer Olympics, so let's just put down for the winter. The values you compare for the distributions when you talk about box plots and things is the median and the interquartile range. So the median for the winter we worked out was 37, and the interquartile range we worked out for the winter was 36. So if I add on the end here interquartile range, then the interquartile range for the summer games was the upper quartile take away the lower quartile. So 199 take away 183, which is 116. And for the Winter Olympics, the number of countries competing, the interquartile range was 36. Okay, so now we've got our values to compare. We can then compare the distributions. Now it's a start question, so they're expecting us to be really clear about what we're doing and interpret the values themselves. So what we can see straight away from the median values is for the Summer Olympics, there was typically on average more countries competing, which seems logical because the Winter Olympics tends to cover just those countries that tend to have cold regions for the winter time. Although obviously Jamaica did in cold running compete in the bobsleigh, although you wouldn't associate snow with Jamaica. But never mind. Anyway, so the number of countries competing. So we had the median for the summer of 121. So what we're going to say then is median average for Summer Olympics was higher at 121, suggesting on average more countries compete in the summer compared to the winter. And then we should compare the interquartile ranges. Well, the interquartile range for the Summer Olympics was 116, and for the Winter Olympics was 36. So the spread of the number of countries for the summer was much wider than the spread for the winter. So we just simply say either way around, but I'm going to do the winter one. The IQR for the Winter Games was much lower at 36, showing the spread of the number of countries was much smaller. Okay, so that would give you full marks for that question because you've interpreted the information and talked about both the median and the interquartile range, and those should be the measures that you use for box plots, cumulative frequency graphs, the higher level techniques. Okay, so that was a quick run through of box plots and interpretation.